Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Mashidu Mamburu. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and is broadcast by our WhatsApp. If you have any question, you will be able to ask questions on 060-667-5044. So that is our WhatsApp for questions. So any question that you are having, you just ask on that number. Well, we're looking forward to this lesson that we will enjoy ourselves. Let's have fun. It's technical science paper 2. The topic, I'm taking the first part, which is naming, nomenclature, naming of organic molecules and structures. So that's what we'll be concentrating on for today. Now, let's start by looking at the performance in 2020 of the organic chemistry. Remember, learners, organic chemistry, you will find it in question 1, multiple choice questions, question 2, question 3, and question 4. So that's where you will find organic chemistry. For today's lesson, we'll be focusing on question 2, which is organic molecules, or you can refer to it as nomenclature. If you look at the performance, is 49%. That was the performance in 2020. So our learners are starting to do well in terms of this topic. Look at the question 3, which is physical properties, 24%. So physical properties is one of the topics that we are still having challenges. You can see 24% in 2020. And then question 4, which is organic reactions, we had 31%. But now, if you compare now with 2021, you will see that question 2 has dropped from 49% to 45%. So with your group, we want you to break the barrier of more than 50% in terms of average for this topic, for this question, which is question 2. But if you can check in the entire paper, this is the topic where the question where our learners are doing very much well. So we're looking forward to you, our learners, doing very well in this question. And we're going to learn a lot. As I indicated, it's nomenclature. This module will focus on 9 homologous series, learners, which is at the IUPAC naming, structural isomers. And then that is for today. We will be doing that. In terms of the topic, organic molecules in paper 2, we have 47 marks, which is 62% of the paper. Now, you will know, learners, that organic molecules make up a big part of our own bodies. They are in the food we eat, in the clothes we wear. They also used to make products such as medicine, plastics, washing powders, dyes, along with a long list of other items. That's why we do organic molecules, learners, is because of all these uses that we can use organic molecules for. As I indicated, these are the objectives, which means at the end of this lesson, you must be able to know the following, learners. You must be able to define organic molecules, homologous series, functional group, hydrocarbons, saturated hydrocarbons, unsaturated hydrocarbons, isomers. Under isomers, you must know the chain isomers, positional isomers, and functional isomers. And you must as well be able to differentiate between primary, secondary, and tertiary alcohols. So we'll look at alcohols. There are alcohols we refer to as primary, secondary, and tertiary alcohols. Sometimes it's the haloalkanes. We do primary, secondary, and tertiary haloalkanes as well. So we'll be looking at that so that when you come to the exam, you are able to remember this. At the end of this lesson as well, you must be able to identify 9 different homologous series. As I indicated, we have 9 different homologous series. I at times refer to it as AAA, which is alkanes, alkenes, and alkynes. And then I refer to the next ones as Hague. I know you like Hague. So that is haloalkanes, aldehyde, ketones, and esters. So we're saying AAA for hydrocarbons, which is alkanes, alkenes, and alkynes. And we're saying Hague for haloalkanes, aldehyde, ketones, and esters. And lastly, I will say AC, which is our alcohol and carboxylic acid. So these are the 9 homologous series that we're going to focus with in terms of paper 2 organic chemistry. Only these 9. For question 2, question 3, question 4, those are the 9 homologous series that we will be focusing on. So it's very much important that you understand them as introduction, so that when you go to other questions as well, you will do well if you understand the structures, which is what we are doing today. For each homologous series, you must be able to know the functional group. For the functional group, you must know the name of the functional group and the structural formula of the functional group. You must be able to write the general formula, molecular formula, and structural formula. So there are three formulas, learners, here that we are going to concentrate on in terms of organic chemistry for technical science. We are saying the three formulas are general formula. So we have the general formula, which is the first formula that you must know. The second formula is molecular formula. Then the third formula being structural formula. So those are the three formulas that we are going to focus on. For all of these 9 homologous series, you must know their general formula, molecular formula, and their structural formula. So that is very much important, because in the exam, the question can be about general formula, molecular formula, or structural formula. So it's very much important that you know which formula is which. You must be able to differentiate between all these 3 types of formulas. And you should be able to identify compounds up to 6 carbon atoms in the parent chain that are saturated or unsaturated. So we'll talk about that. What do we mean saturated? What do we mean unsaturated? And you must be able to write down structural formula for given isomers and name the isomers. So we're going to do isomers, and which is writing their structural formula and naming them. We must name them and know how to write their structural formulas. So we're going to focus on that. At the end of this lesson, you must come back to these objectives and look at them and say, do I understand all of these aspects? If you understand everything that is on this, then we will be able to say our job is well done. Now, organic molecules, these are molecules containing carbon atoms. Sometimes this definition of organic molecules, you can take it for granted. It was asked in one of the papers, I think, last year, in 2019. It was asked to say define organic molecules. So it's very much important that you must know this definition. What is organic molecule? So we're saying organic molecules are molecules containing carbon atoms. It might look like a simple definition, but you must know it. It has 2 marks, learners. So we're simply saying know what is organic molecules. We're saying these are molecules containing carbon atoms. So it means here for our study, you must be able to understand that when you see a structure that is made up of carbons, you start to think of organic molecules. So I always want to make this example to say, if you look at that structure, it's made up of carbons and hydrogens. So that is an organic molecules. But we have an example like carbon dioxide. Carbon dioxide, CO2, it has carbon, but it's not an organic molecule. So you have to know that there are exceptions. It doesn't mean that if you have carbon, you are now qualified to be an organic molecule. So we'll refer to the first structure there as an organic molecule, and carbon dioxide will refer to it as inorganic molecule. So you must know that we have organic molecules and inorganic molecules. Organic molecules, we're saying they are made up of carbons, but I gave carbon dioxide as an exception, that it has carbon, but it is not an organic molecules. These organic molecules, we're saying each carbon is surrounded by 4 bonds. So there must be at all times 4 bonds around each carbon. You'll remember that carbon is number 6 there. So we're saying that 6 stands for the number of electrons. So it has electrons that we can refer to as 1s2, 2s2, and 2p2. You will remember, learners, the p orbital is supposed to have 6 electrons. So it's running short of 4. In real sense, if we look, we're saying that this second energy level, the 2s and the 2p, it must have 8 electrons in total, which means that in a carbon is running short of 4 carbons. So we say it has a valency of 4, which means around a carbon there are 4 electrons which are not paired. So there are 4 electrons that are not paired. Then that's why these electrons are the ones that are going to form bonds. So these electrons, they can form bonds with hydrogens. So if we bring a hydrogen, it will bond with that, and another hydrogen, it will bond with that electron, and then we bond like that. Then maximum 4. You can see, because carbon is tetravalent, it means it has 4 electrons in its outermost energy level. It means that it can only form maximum of 4 bonds around it. So we're saying, as you can see in the structure there of CH4, there are 4 bonds that are formed. Remember, each bond indicates the number of electrons. So if you are having CH4, for example, you must know that is 1 electron from hydrogen and 1 electron from carbon. So when you see that line, you must respect it because you know that it symbolizes 2 electrons that are being shared between a carbon and hydrogen. So we say this is sharing of electrons. So we refer to that bond as a covalent bond. So it's a covalent bond. So you must know here we'll be talking mostly about covalent bond because when we talk about these organic molecules, they form covalent bond, which means they share the electrons between them. So the most important thing that I'm talking to now is a carbon. I'm saying understand that a carbon is tetravalent. It can form 4 bonds around itself because it has 4 electrons, valence electrons. So we're saying those valence electrons are the ones that are going to form the 4 bonds around a carbon. So it's very much important all the time when you're drawing structural formulas. Always have that in mind, that carbon cannot have more than 4 bonds. So all the time count the number of bonds around a carbon so that we're able to move forward. So you can check on the structure I've given you as an example. You can see that you have a carbon. There is 1, 2, 3, 4 bonds around that carbon. So you must go to each of those carbons. You'll understand hydrogen is number 1. It has 1 electron. So you can only share 1 electron. You can't have 2 bonds, double bond towards a hydrogen. That's why you will see the hydrogens are forming 1 bond with the carbon. And I said that bond, we refer to it as a covalent bond because there is sharing of electrons between carbon and hydrogen. I hope we are still together in terms of that one. So the main thing the first thing I talked about in this lesson is that a carbon must form 4 bonds around it at all times, not more than 4 bonds around it. And we are saying this carbon is very wise. It can form bonds to straight chain and branch chain. So we'll look at those 2 types of chain. The other chains will be straight, the other chain will be branched. So we're going to look at that. Which chains are straight, which ones are branched. Because of this, long chain structures can form. So you'll understand as we move forward to say when do we form this straight chain and branch chain. Now, as we start this lesson now, we start with homologous series. Remember, our first definition was what is organic molecules. We said these are molecules containing a carbon. So they contain carbons. And then now, the second definition, we're saying what is homologous series. We're saying a homologous series is a series, obviously, it will start with a series of organic compounds. So we're talking about organic compounds here. So we'll say it's a series of organic compounds that have the same general formula or that are described by the same general formula. They are described by the same general formula. Remember, I said there are 3 formulas that you must know: general formula, molecular formula, and structural formula. For now, I'm saying for homologous series, we are still talking about general formula. So we're saying when it comes to homologous series, they are described by the same general formula. And each member differs from the next by CH2. I'm going to demonstrate that to you during the lesson so that you are able to see how each member differs from the next. You will see that when we start with our hydrocarbons. So we said there are 9 different homologous series that I'm still singing the same song because I want you to understand that song. To say we're saying AAA, which is alkanes, alkenes, and alkynes. We're saying Hake, which is haloalkanes, aldehyde, ketones, and esters. So you got to know that. And then we're saying AC, which is our alcohols and carboxylic acid. So know them. We're going to differentiate between them. Remember, all these 9, we call them homologous series, which means all alkanes have the same general formula. And for all alkanes, each member will differ from the next by CH2. I will show that when I do the alkanes, alkenes, and alkynes with you just now. Now, the same when you go to alkanes, they will have the same general formula. Aldehydes, they will have the same general formula. Ketones will have the same general formula. Esters will have the same general formula. Alcohol, same general formula. And carboxylic acid will as well have the same general formula. So I'm singing this song of formula so that you understand that is the most important part, because if you know the general formula for all of them, we're going to move from general formula to molecular formula. From molecular formula, we're going to move to structural formula. So it's important that you understand those formulas that I referred to. Now, we're saying, how are you going to differentiate these homologous series? Because we're saying there are 9 homologous series. So now, we said they have the same general formula. They differ, or each member differs from the next by CH2. Now, how are you going to differentiate between alkanes and alkenes, for example? Or how are you going to differentiate between alkynes and haloalkanes? How are you going to differentiate between aldehyde and ketones? So that is the question I'm responding to now. You will differentiate them by using the functional group. It means each homologous series has its own functional group, which means a homologous series differs from the other homologous series by functional group. So how will they know? How will you know them? How will you know them? If somebody is asking a question, how will you know that this is your teacher for today, Mr. Mambur? How will you know it's him? So you would look at something that you can identify Mr. Mambur with. I don't know what is that, but I'm saying that is how we're going to differentiate. In terms of organic molecules, you differentiate them using the functional group. So from one homologous series to another, the difference will be the functional group. I hope I've put that clear for you. And then what is important is that we must know the definition of a functional group. What is this functional group? So we're saying, I usually will say here is a bond, is an atom, is a group of atoms. But if you look at the exam guideline that we're having, it starts now with it's an atom, it's a group of atoms that determine the chemistry of a molecule. So we're saying you're going to look at the atoms and the group of atoms that determine. It means the difference between alkanes and alkenes. We're going to look at that. What is the difference? Because I said you differentiate within the homologous series, you differentiate them using their functional group. So we'll look at the functional groups of haloalkanes, of aldehyde, then we see how they differ from one another. So the definition of functional group is that it's an atom, it's a group of atoms that determine the chemistry of a molecule. For you not to forget, I usually will say it's a bag, the B for the bond, the atom, the group of atoms that determine the chemistry of a molecule. So when you want to know the chemistry of a molecule, you will know them through their functional group. We're saying how they behave, their physical and their chemical properties will depend on the functional group. It means if you are going to do, for example, when you do question 3, we're going to react these different homologous series. When they react with one another, we know that it is the functional group that will be active in the reaction, because how they behave is because of the functional group. So it's important that you know our third definition. The first one, I defined organic molecules for you. I define homologous series. And the third one now, we're defining what is a functional group. These are marks that you must collect on definition. If you look at our papers, all our papers, they start with such question of saying define, define, define. So it's important that you get definitions, but let's define according to the exam guideline, because if you define in your own understanding, then you might leave some keywords, then you will lose some of the marks. So the first thing we looked at is the functional group. Now we are saying the functional group is a bond, an atom, group of atoms that determine the chemistry of a molecule. Now we move to the general formula. The general formula, remember I said we have 3 formulas here. The general formula being the first one, the molecular formula being the second one, and the structural formula being the third one. So the general formula we're saying is an expression used to indicate the distribution of atoms in an organic compound in a homologous series. And we're saying molecular formula is a chemical formula that indicates the type of atoms and the correct number, how many are they of each in a molecule. So we're saying how many carbons do we have, how many hydrogens do we have. Whereas for general formula, we're just telling you about the distribution of atoms in an organic molecule. But for molecular formula, we're saying correct. What is the correct number of carbons, correct number of hydrogens? It indicates only the number of atoms of each element in a molecule. However, the structural formula of a compound, it shows atoms are attached to which within the molecule. It shows the bonds and the atoms in a molecule. So you'll remember as I was drawing that structure, I was able to do the structural formula. So we'll be looking at all the 3 formulas, but I want you to understand them in that order: general formula, molecular formula, then structural formula. I hope we are still moving together in this nice topic of organic. In fact, you must get so many marks in terms of organic. You must get 100% here. So we're saying, how will you name now? How are you going to name these organic molecules? How are you going to name them? We're going to start with hydrocarbons first. How we're going to name them? We're going to name each of them according to the number of carbons that it has. So we're saying if a molecule has one carbon in the longest carbon chain, I must clarify that. If it has one carbon in the longest carbon chain, it will make sense as we go on with the lesson. So if it has one carbon in the longest chain and 2 carbons, 3 carbons, 4 carbons, 5 carbons, 6 carbons. Remember, we do up to 6 carbon in technical science. We're not saying organic chemistry is up to 6 carbons, but for technical science, we do only structures that has 1 carbon until 6 carbons. So we're saying 1 carbon, you will give the prefix. Prefix is name starting. The name will start with pre, means before. Pre means before. So before the name will start with meth if we have 1 carbon. So all your job is very simple, is to look at the number of carbons. If it's 1 carbon, you say meth. If it's 2 carbons, you say eth. If it's 3 carbons, you say prop. 4 carbons, you say but. 5 carbons, you say pent. And 6 carbon, you say hex. I've been trying to find a simple way of putting it, so it gives me map there, BPH. So I'll say map BPH so that you don't forget this, that the first one is 1 carbon, the second one is 2 carbons, the third one is 3 carbons, which is prop, the fourth one is 4 carbons, which is but, the fifth one is 5 carbons, which is pent, and the sixth one is 6 carbons, which is hex. So you have to understand that map. Where's the map going? It's going to BP, and then next to the H. You can think maybe the H is the hospital or is the hotel. I don't know where the map is going. So I'm saying that map BPH is for you to remember that 1 carbon, we say meth, 2 carbons, we say eth, 3 carbons, we say prop, 4 carbons, we say but, 5 carbons, we say pent, 6 carbon, we say hex. So remember map BPH so that you don't fail to name the structures. I'm hoping that we are moving together. I'm saying to you now, for you to be able to name the structures, you look at the number of carbons. How many carbons do we have? So if you have 1 carbon, you know it's a meth, 2 carbons, eth, 3 carbons, prop, 4 carbons, but, 5 carbons, pent, 6 carbon hex. This is very much important, learners, because this is your foundation for question 3 and question 4. Remember, there are 3 questions you're going to answer based on these organic molecules. It's question 2, question 3, question 4. For today, we're focusing on question 2, which is naming of structures and isomers. So that is what we will be doing. So it's important that you understand everything in this lesson so that the other lessons will just become a walk in the park. I hope we're still together. We're moving together there. Now, as I indicated, we'll start with the hydrocarbons. As the name say itself, hydro is taken from the word hydrogen, carbon from the carbons. So it means these are, always you will see that our definition will always say organic molecules because we're talking about organic molecules. So when you are starting to define, you remember we said homologous series is a series of organic molecules. It's a series of organic molecules that are described by the same general formula. So you see, we always start with the what? Organic molecules. Even here, hydrocarbons, we are saying organic molecules made up of hydrogens and carbons only. So these definitions do come in the exam. So you know we're doing organic molecules. You just say organic molecules made up of what? Hydrogens and carbons, because you know. But if we don't say only, your definition becomes wrong. That keyword, remember I said you must be able to write definitions correctly. If you say hydrocarbons are organic molecules, correct. Made up of hydrogens, correct. And carbons, correct. But if you don't say only, your definition becomes
Believe in
wrong.
yourself.
Remember,
believe a little more in yourself, because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing, because this can be done and you can be great. You have been given power to decide whether you want good results in your life, in your schoolwork, or you want bad results. As Tony Robbins said, it is in the moment of your decision that your destiny is shaped. And your destiny is shaped right now.
Welcome back. Hoping you enjoyed your short break. Remember, we said all the questions, send them to 060-667-5044. So we're enjoying our lesson. We're busy talking about hydrocarbons. So I think I emphasized enough to say when we define, we're dealing with organic molecules. So we're saying hydrocarbons are organic molecules. What are they made of? They are made up of hydrogens and carbons. I said it's important that you say only. If you say it's made up of hydrogens and carbons, your definition will be wrong. Because if I'm to write a structure which is made up of hydrogens and carbons, but with the OH, for example, there, so you will see that now it becomes, this is not a hydrocarbon, because a hydrocarbon, we are saying, is made up of hydrogens and carbons only. So that oxygen, it takes away the only part. So it's very much important that if you don't write only, it means you are saying even the structure is made up of hydrogens and carbons. So you will be saying this structure is a hydrocarbon, which is wrong, because we know it's an alcohol, which we are going to talk about them. So it's very much important. Immediately when you say only, you are saying no any other atom or molecule that must be attached to that structure. So we're saying continue like that. And when you define, always say it's made up of hydrogens and carbons. I underline the word only and I emphasized it. Remember now, this is our fourth definitions. This first definition, we define organic molecules, we define homologous series, we define functional group. Now we are defining hydrocarbons. We're saying it's made up of, these are organic molecules made up of hydrogens and carbons only. I underline the word only because it's the most important part. So immediately when you say only, you will be able to get that. We have two hydrocarbons that we talk about, which is the saturated hydrocarbons and the unsaturated hydrocarbons. So you must know that at the top we're having hydrocarbons, and then these hydrocarbons they are either saturated or unsaturated. So I will usually say saturated. You see saturated start with an S there. So you can say it contain only, that S is for single. It contain only single covalent bonds between carbon atoms. Remember I said the bond, we're sharing electrons, so it's covalent bond. So we're saying saturated, they contain only single covalent bonds between carbon atoms. That only as well is important. That's why I put it in bold there to say it's only single covalent bonds between carbon atoms. If, for example, you say saturated, they contain only single covalent bonds, you stop there. I will give you a carbon bonded to a hydrogen. If a carbon is bonded to hydrogen, that is a single covalent bond. But that bond is not between carbon atoms. For it to be saturated or unsaturated, we look at the carbons. The carbon that is bonded to another carbon, are they single bonds or double bonds? Look at it that way to say it must have only single bonds between carbons. For example, if I'm to write that structure like that, it will now become saturated. We'll refer to it as saturated because it's made up of single covalent bond between carbons. So the bonds that we are interested in is the bond between carbon-carbon bond. There must be single bond between the carbons. So that's what is important. So don't forget, we're saying saturated, S for single. So you know that is contain only single covalent bonds between carbon atoms. And unsaturated is like you are removing the single now. You are unsingling it. Now it becomes, for the lack of a better word. Now you are removing the single bond, or you are replacing the single bond with a double bond. Then it's now unsaturated. It means unsaturated means that it contains covalent double. We can form double bond or triple bonds. So we're saying that, understand, we're saying, okay, when we're starting, we're having our structure there, which is carbon bonded to carbon, and we refer to this structure as saturated, because between carbon and carbon there is a single bond between them. Now, if we look at our structure here, let's say, for example, I said to you, between carbon and carbon there must be single bonds, then it qualifies. If it's only single bonds between carbon and carbon, then it qualifies to be saturated. So we'll refer to this structure as being saturated hydrocarbon. So it's saturated carbon, it contains only single covalent bonds between carbon atoms. You can see there, between those carbons, there is a single covalent bond. So you will refer to that as a saturated. Unsaturated, we are saying now between carbon and carbon, we now have a double or a triple bond. The presence of a double or a triple bond will change from being saturated. The structure becomes unsaturated. I wanted to use this structure to demonstrate. Remember, we said each carbon must have 4 bonds around it. So if you can look at this carbon, it has 4 bonds around it. So it's correct. This other carbon, let's look at it as well. It has 4 bonds around it. So all the time, a carbon will have 4 bonds around it. Now, if, for example, I put a double bond there. If, for example, I put a double bond there, you see now, when you look at the number of bonds in each carbon, there will be more than 4, which is 1, 2, 3, 4, 5, which is not correct. You know, when we started, we said a carbon can only form 4 bonds, which means when we bring a double bond, we must remove a hydrogen from each of the two carbons that we are having. So when we put a double bond there, we must remove one hydrogen and another hydrogen. Hence, the structure now becomes like that, which is now no longer single bonds. It's now double bond. Then, if we were to put the third bond there for it to be triple bond, as well, we must remove 2 hydrogens. So you can see, for each bond that we are increasing, when we move from single bond to double bond to triple bond, when we're increasing the number of bonds, we remove 2 hydrogen, each from the 2 adjacent carbons. So you can see that for us to have a double bond, there must be hydrogens that must be sacrificed, so that we are able now to move from saturated to unsaturated. So unsaturated, we have 2 types. The other ones, they have double covalent bond. The other structures, they have triple bond between carbon atoms. So you have to know that if it's a double covalent bond between carbon atoms, we will refer to that as alkenes. I'm coming to that now. Remember, when I started, I said we have 9 homologous series in technical science grade 12 that we do. When you study further, you might do as many other organic molecules as you can, homologous series. But for our studies, we are focusing on these 9. So we are saying AAA, which is your alkane, alkene, and alkyl. We're saying alkanes, they are saturated. Why are they saturated alkanes? They contain only single covalent bond between carbon atoms. So these ones, we refer to them as alkanes. They are saturated. So when we now have a double bond, when we have a double bond there, in terms of the structure now becomes the alkene. So we're saying when you move from alkane, you have to remove 2 hydrogens. Remember, I said from single bonds to double bonds, you remove 2 hydrogens. So what we are going to do, what we have done here, we had an alkane, we removed 2 hydrogens, it becomes an alkene. Then we remove further 2 hydrogens, it becomes an alkyl. So as the number of bonds increases, the hydrogens are removed. Now, this is very much important, learner, so that you understand where we're coming from and where we're going. Remember I said we have 3 formulas that we must be able to understand. Now, for alkanes, we must be able to know for alkanes what is the general formula. The general formula for alkanes is CnH2n plus 2. So this is important. This is the first formula that we are doing. We refer to it as a general formula. We're saying general formula is CnH2n plus 2. So you have to know that the N there stands for the number of carbons. So we're saying how many carbons do we have? N, let me write it. N stands for number of carbons. Number of carbons. So you have to know in the general formula, the N represents the number of carbons. So we're saying CnH2n plus 2. So that is the general formula for alkanes. Now, the 2 there are the hydrogens. That 2, it represents the hydrogen. So you will remember, we said when you move from an alkane, from a single bond to a double bond, you have to remove 2 hydrogens, which means the general formula for alkenes, for a double bond, when we have a double bond, for alkenes, the general formula will be CnH2n. We have removed the 2, which represent the two hydrogens that we remove when we bring a double bond. When we move from a double bond to a triple bond, we said we'll remove another 2 hydrogens. So the general formula will be CnH2n minus 2. So you understand that okay, we have 3 hydrocarbons that we have learned so far. The 3 hydrocarbons, 1 is saturated, the other 2 are unsaturated. The saturated, we are referring to it as alkane. Alkane, it has maximum number of hydrogens that you can have, because we said carbon can only have 4 hydrogens around it. So it has maximum number of hydrogens that it must have. But immediately when you move from alkanes, which have single covalent bonds, when you move to alkenes, which have a double bond now, you sacrifice 2 hydrogens. That's why the general formula for alkanes is CnH2n plus 2, but for alkenes is CnH2n, no more 2, because the 2 it represents the 2 hydrogens that we have removed. I hope you get that one. As well, when we move from alkenes going to alkynes, we're going to remove further 2 hydrogens. So the structure will become CnH2n minus 2. So you know that, we have 3 general formulas we've learned today. Is the general formula for alkanes. Alkanes, they have single bonds, which means we have maximum number of hydrogens that we must have. And then because of that, the general formula is CnH2n plus 2. However, when we move from alkanes to alkenes, we'll remove 2 hydrogens. When we remove 2 hydrogens, the general formula becomes CnH2n. When we remove further 2 hydrogens to form triple bonds, the general formula becomes CnH2n minus 2. The minus 2 is saying further 2 hydrogens were removed for us to have a triple bond. I hope and pray that you now understand the general formulas for alkanes, for alkenes, and for alkynes. So you have at all times, as I indicated, I said we have 3 formulas. So I've spent much time trying to explain to you so that for you to understand that the general formula for alkanes, alkenes, and alkynes. For the last time, as I move from this aspect, I'm saying alkanes, they have maximum number of hydrogens. So is CnH2n plus 2. But alkenes, because of the double bond, we sacrifice 2 hydrogens, which means now the formula won't remain CnH2n plus 2. We'll remove the 2 hydrogens so that we get the double bond. So the formula will become CnH2n. When we move to alkynes, we'll sacrifice further 2 hydrogens. Then the structure now will be CnH2n minus 2. So you know the general formula for alkanes, alkenes, and alkynes. That is the first thing that you must know. General formula for all the 9. Remember I said we have 9 homologous series. I'm starting with hydrocarbons, which are these 3. We said the hydrocarbons, they are made up of hydrogens and carbons only. They are organic molecules made up of hydrogens and carbons only. What are they? Alkanes, alkenes, and alkynes. And we are saying alkanes are saturated. Saturated start with the word S there, with the letter S. So we're saying that letter must remind you single covalent bond between carbon atoms. So saturated is single covalent bond between carbon atoms, but S, so we're removing the single, we're replacing the single bond with a double bond or a triple bond. So it's unsaturated. So it must have a double or triple covalent, at least a double or triple covalent bond between carbon atoms. Remember at all times, between carbon atoms. The double bond between carbon atoms. If it's between carbon and oxygen, it has nothing to do with the saturation. We're saying for saturation and for saturated and unsaturated, we are looking at the double bond between two carbons, because some of the time learners becomes confused. You will see when you do other homologous series, they confuse when they see C double bond O. So it's no longer between two carbons. So we are referring here, when we talk about saturated and unsaturated, we are referring to carbon-carbon bonds. If it's carbon-carbon single bond, it's saturated. Carbon-carbon double bond, unsaturated. Carbon-carbon triple bond, unsaturated. And the unsaturated, we said if it's a double bond, it's alkanes. If it's a triple bond, it's alkynes. So it's important that you understand alkanes, alkenes, and alkynes. Hence, I've been singing that song so that you understand this, because this is your foundation. As we move to other homologous series, if you have understood this one, it will be easier for you to understand the rest of them. So I'm just recapping for you. We defined organic molecules. We defined homologous series. We define functional group. We define hydrocarbons. And we're saying hydrocarbons, they have saturated and unsaturated. So we define saturated. We define unsaturated. So those are the 6 now definitions that we have been doing. So we're saying saturated, unsaturated. Saturated, only alkanes are saturated. So the general formula, CnH2n plus 2. When we move from alkanes to alkenes, when we have double bonds for alkenes, double bond, we are saying because now there is a double bond, now we're going to remove 2 hydrogens. The general formula will be CnH2n. When we move to alkynes, the general formula will be CnH2n minus 2. I hope that is cleared. We are together in terms of that. Now, remember what we said, learners, when we started here. I showed you a slide. I said 1 carbon is meth, 2 carbons is eth, 3 carbons is prop, 4 carbons is but, 5 carbons is pent, and 6 carbons is X. We said MAP BPH. MAP BPH. Remember that? So we are saying when you look at these structures, you will know. You will say, okay, how many carbons do we have here? Oh, it's 2 carbons. So 2 carbons, we said it's eth. So you would look there. You say it's 1, 2. All the time you are looking for the longest chain. And then how many carbons do we have in the longest chain? Now in the longest chain, we have 2 carbons. You will come here and say 2 carbons, it must be eth. But you have to now know whether, remember we said this is a prefix. We refer to this as a prefix. So your prefix is eth because of 2 carbons. So the name will start with eth because of 2 carbons. Now we're going to look for what is referred to as suffix. Now we'll talk to the suffix, the name ending. What will the name end with? Because the name will start with eth because it's 2 carbons. So that's where you start. Say, how many carbons? 2. You go and say, oh, 2 is eth. Then suffix is the homologous series, it's the functional group. Which homologous series does it belong to? Let's go. The eth, this first one, we said is alkane. So you can see the word alkane, it ends with A-N-E, which means we're going to take for suffix, we take the tail end of that, which is the ane. Then it becomes the name of the structure will be ethane. So you can see what we're doing. We're taking the prefix, which is determined by the number of carbons. Then we're taking the suffix, which is determined by the homologous series, to say which homologous series. And the homologous series alkane, it ends with A-N-E. That's why now we're saying this structure, we're going to refer to it as ethane. Why ethane? Eth is 2 carbons. Ane is the homologous series which it belongs to. I hope that clarifies everything. You will enjoy naming them. Now let's move to the second one. We had 2 carbons. 1, 2. So all the time you're counting the number of carbons. How many carbons? 1, 2. So we have 2 carbons. It's eth. So you know that this is eth. Why? We have 2 carbons. But between carbon and carbon, how many bonds we have? We have a double bond between carbon and carbon. When we have a double bond, we go, which homologous series is alkene? Alkene, as the name says, it ends with E and E. So because it's alkene, it will be ethene. How good is that? So I hope you will enjoy. So now all you will do, look for longer structures, then count the number of carbons, then go and look for the prefix to say what is the prefix, and then look at the suffix from the homologous series. You add it at the end of the name. Let's look at the last one there, which is our alkyl. Still, we are having 2 carbons, 1, 2. So you will say eth, because it's 2 carbons. Always when it's 2 carbons, it's eth. So it's eth because of 2 carbons. Now we are saying we have a triple bond. Triple bond, we said these are alkynes. So you will go and take Y and E, or the name ending. Alkyne, you will take the last part, which is wine, which means the structure, you will refer to it as ethyne. So you can see how we name them. Prefix, number of carbons. Suffix, homologous series. So I hope you will enjoy naming as many structures as you can do. Now, remember I talked about formulas. General formula, I hope you understand by now. CnH2n plus 2 for alkanes, CnH2n for alkenes, CnH2n minus 2 for alkynes. Then, when you remove the N, we're going to look at that now. When you remove the N, you're going to get the molecular formula. So when you say how many, let's say for example, ethane. We want the molecular formula of ethane. We said how many, N is the number of carbons. Let's look at that. The general formula will be CnH2n plus 2. I will write here CnH2n plus 2. Now I hope you see what I'm writing. So that's CnH2n plus 2. Because carbon, we have in ethane, we have 2 carbons. You must replace N by 2. So it will be C2H. 2 times 2 is 4, plus 2 is 6. You see where the 6 is coming from? Let me be slow there. N is 2. So where there is N, we write 2. So I'll say C2H 2 times 2. N we said is 2. So 2 times 2 is 4, plus 2 is 6, which means our structure is C2H6. You see now, we have moved from general formula to molecular formula. So when we replace N, we go to the molecular formula. What we have drawn here, these 3 structures, this is what we refer to as structural formula. So you see the 3 formulas that I talked about. So we're moving from general formula, then the number of carbons, which is N, will tell us which molecular formula we're going to get, depending on the number of carbons. So we get the molecular formula. From there, for structural formula, you indicate all the bonds. So no bond must be left out. You can see we've shown all the bonds. We're having 2 carbons bonded to each other, and then we show the 6 hydrogens that are attached to those carbons. I hope you understand now the 3 formulas that we talked about, and it will help you as you move in any homologous series that you will be dealing with. So you will be able to understand that. Nicely, what I was talking about there, I nicely indicated for you here so that you can see it clearly now. To say alkanes, they have the general formula CnH2n plus 2. But if you look here, we have a structure of 4 carbons. Remember what we said. You will check how many carbons we have. 1, 2, 3, 4. Longest carbon chain. 4 carbons. According to our map there, we said map BPH. So you know that the boot is number 4. 1, 2, 3, 4. Boot is number 4. So you know this is a prefix. 4 carbons means boot. So you know that is boot. Then you say, okay, this is boot. Then you say, do we have any double bond or triple bond? You say no double bond, no triple bond, only single bond. If it's only single bond, you know it's in alkane. So when it's alkane, you say this structure is butane. You see that? So you now know how to name them, because always you're going to your key there to look for which one, which number, how many carbons do we have. Now, from general formula, you said we have 4 carbons, you just substitute N there with 4. Where there is N, you write 4. You say, okay, I have 4 carbons. Okay, N is 4 because we said N is the number of carbons. So you will simply say C4H. 2 times 4 is 8. 2 times 4 is 8 plus 2 is 10. That's where the C4H10 is. In the exam, we can give you butane and say, write down its structural formula. You will draw it like that. We can give you the name butane and say, write down its molecular formula. Write down its general formula. It means the questions are all about around there. We're saying, okay, we gave you butane now. We want you to give us the structural formula. We want you to give us the molecular formula. We want us to give you to give us the general formula. So the questions are coming from there. So immediately when you see a structure, you can formulate questions because you know we are going to look for the formulas to say which formulas they belong to. So because the only thing we're going to say which homologous series, you say, okay, this is alkanes. They are alkanes. So you know homologous series, we said is AAA, Hague, AC. So these are alkanes. So that is the homologous series. And then we'll talk about functional group just now. And then so that I can show you how to see which one is the functional group there. Then that's all we're supposed to do. So all I was explaining is nicely shown in this slide. I hope you are understanding everything. If you have questions, continue to ask those questions. We said our WhatsApp number is 060-667-5044. So continue to ask questions if you have any question. But I'm hoping we are moving together and you are enjoying the lesson. So for alkenes, we said CnH2n. Then when you replace with the 4 there, it becomes C4H8. You can see that when we move from alkane, there were 10 hydrogens. When we move to alkenes, they become 8. So it shows that we sacrifice 2 hydrogens so that we can have a double bond between carbons. When we move to alkynes, still we sacrifice another 2 hydrogens so that we can have a triple bond. So you can see we move from 10, we subtract 2, we become a double bond. We subtract another 2, we get a triple bond, which is what I've been explaining. So I'm hoping that you have understood now how we move from general formula, molecular formula, structural formula. So we are saying all these are 3 homologous series. They have different general formulas. And then from general formulas, when you substitute the number of carbons, you are able to get the molecular formula. When you show all the bonds, you get the structural formula. And the naming, I've shown you the naming. You will look at the prefix. How many carbons do we have? Then the number of carbons is the prefix. Then the homologous series will give you the suffix to say what will be the name ending. So you can see we're saying butane. I showed you why we're saying butane. Let's go to butene. We're saying how many carbons? 1, 2, 3, 4. So you come here, you say it's but. 4 carbons is but. So you will write but there. And then you are saying now to have single bonds, double bonds, or triple bond, you say we have a double bond. You know, double bond is ene, is alkenes. So you know that it's an ene now. But the most important part when you go to unsaturated learners is to ensure that you look at the position of the double bond. Look at our double bond now. Is in carbon number 2. So it doesn't matter because our double bond is in the middle. So you can number 1, 2. I'm going to do that when you do naming to show you how do we do the numbering. So you can say 1, 2, 3, 4. So you are simply saying, okay, 4 carbons is a but because of our prefix. And then in carbon number 2, we find a double bond, which is ene. So that's why we call it but to ene. So we're saying in carbon number 2, we have a double bond. So always you have to tell us where do we find our functional group? Where do we find our double bond? In which carbon do we find the double bond? And look now, I'm bringing something new. When I write the but, I put the hyphen there, that dash. Without that hyphen, learners, always when you are using, you are having an alphabet and a number, you will use the hyphen to connect them. You will use the hyphen to connect them. Remember, this is one name. But to in is a one name. It's not 2 different names. It's one name. The only thing is that you use the hyphen in between the number and the alphabet. So all the time, alphabet and number, you use the hyphens to connect them. I hope you understood that. So we're saying but 2 in. It means in carbon number 2, we have a double bond. Let's go to the last structure that we are having, that this one of a triple bond. So you will as well look at the number of carbons. How many carbons do we have? You are saying 1, 2, 3, 4. We're having 4 carbons. So you say, 4 carbons, I know. It's a what? It's a boot. But where do we find the triple bond? Where do we find, in which carbon? So that is what is very much important. In which carbon do we find our triple bond? So that will be boot 2. You can see 1, 2, 3, 4. So you are able now to say, in carbon number 2 again, we're having a triple bond. So triple bond is no longer alkene, it's now alkyne. So you will write Y and E at the end of the name. Both 2 wine, like that. I hope you got it and you will enjoy. So look as many structures as possible. Count the number of carbons. Go and take the prefix. When you are done, look at from which homologous series they belong. Immediately you remember about the homologous series. You are saying this is the suffix. Homologous series will tell you which suffix, the name ending. How will the name end? You are taking it from the homologous series. For example, alkanes, the suffix will be "-ane", alkanes "-in", and alkynes "-wine". So you know that. And then we are saying always when you have a number, you must be able to do what? To write the hyphen or to have that dash between the number and the alphabet. I hope you will enjoy this part. Continue to ask questions. If you have questions, we'll respond as we move forward. Now, this slide is just emphasizing what we've done already. Remember, this is still our map BPH. Don't forget, wherever you go with our map. We said map BPH. So everywhere you go, map BPH. So you know that, okay, look at that. See, we have 1 carbon there. So that is the molecular formula. You know now the molecular formulas and structural formulas. So the molecular formula for methane is CH4. So is CH4, there are no double bonds, so you know that is methane. Eth, when there are 2 carbons. Prop, boot, and then you can see there is supposed to be C5H12. So it's C5H12 for pent, and then that is pentane, and then C6H14 there, C6H14. But this side they are correct on the other side, so it's not a problem. So as we move now, we are saying methane, ethane, propane, butane, pentane, hexane. Remember, we took the prefix from map BPH. We took the suffix from the homologous series, which is "-ane" for alkanes. Yeah, I think this slide, it does justice. So the MF is just short molecular formula. You can't write MF in the exam. You call it molecular formula. I was just doing it for simplification. So molecular formula, you have C2H4. You can see that we have removed 2 hydrogens from C2H6. Now it becomes C2H4. So you know that when we remove 2, we have a double bond. It's no longer ethane, it's now ethene. It's now ethene. When you remove another 2 hydrogens, it now becomes ethine. So it's very much important in the exam, because we can just give you C2H2, and then we can ask you now a question to say, is this saturated or unsaturated? So you will know that I know the general formula for saturated for alkanes is CN H2N plus 2 for alkanes. For alkanes, I know is CN H2N plus 2. So you will definitely see that, C, how many carbons? N is 2. So it's C2 H2. You know that 2 times 2 is 4 plus 2 is 6. So you know that if it's not 6, it means we have removed. How many did we remove? We have removed 4. Then you know it's an alkyne, because when you remove 4 hydrogens, it means it's an alkyne. When you remove 2, it means alkene. So you will be able to know that. But the number of carbons will always tell you here, because you will know, say, it's eth. It's eth, but because now it's C2H2, it means we have removed 4 hydrogens, which means we have moved from single bonds to triple bonds. So you know that for alkynes, 4 hydrogens have been removed. For alkenes, 2 hydrogens have been removed. So you be careful of that, so that because in the question you will be given one of those 3 formulas that I talked about. It either will give you the general formula, molecular formula, or structural formula. So we can ask them around. So know all of them and enjoy drawing all of them. So if I'm you, I will ensure that I know how to draw for all the homologous series. I know how to draw the general formula, the molecular formula, and the structural formula. All of them. We're only doing up to 6 carbons, maximum of 6 carbons. So you can do all the structures for all the 9 homologous series, draw all of them, know them, take a book, draw all from alkanes. You draw from 1 carbon to 6 carbons, all those structures. Go to alkenes, draw all of them. Look, Leonard, for alkenes, we don't have methane. Can you see that? We have methane with 1 carbon, but we don't have methane, or we don't have methane. Can you see that? No methane, no methane. Why? You are asking yourself that question. Remember what I said. The double bond must be between 2 carbons. So we don't have 2 carbons in meth because it's only 1 carbon in meth. Meth is for 1 carbon. So it's only CH4 that we can have. We can only have methane because there are no 2 carbons. So we can't have alkenes with 1 carbon. We can only have alkanes with 1 carbon. But alkenes and alkynes, they start from 2 carbon upward. So understand that and enjoy that. So we're simply saying continue to ensure that you understand that, okay, for alkenes and alkynes, they start from 2 carbons upward. Why? Because we said the double bond must be between carbon atoms. So there must be 2 carbons so that we have a double bond. There must be at least 2 carbons to have a double bond, or to have a triple bond. So you can see our structures as we move. Look at propane. Prop, we said it's 3 carbons, so it's propane. When we remove 2 hydrogens, it's propene. When we remove another 2 hydrogens, it's propyne. Now, I hope we're moving together. Then when it's 4, we said it's but. So you can see but there. So that is butane. When we remove 2 hydrogens, it becomes butene. Remember now, because this but, it has 4 carbons. Remember, but has 4 carbons. Now, we have an option of having a double bond in carbon number 1 or in carbon number 2. That's why now we can have but 1 in and but 2 in. So we have 2 options. We can have a double bond in carbon number 1 or a double bond in carbon number 2. Remember, if we bring the double bond on this carbon will become carbon number 1. When we are numbering, I'm going to tell you, teach you about the numbering of carbons, how we number them. You will see when we are doing naming. There's no problem on that. So I'm saying this is carbon number 1 because it's closest to the double bond. So when you are numbering your carbons, you will look for the double bond to say where the double bond is. That's closest to the double bond. That's where I will start my numbering. So I'm saying your carbon number 1 will be this carbon. Your carbon number 2 will be that one. Your carbon number 3, and then your carbon number 4. So we'll refer to this structure as but 1 in because the double bond is in carbon number 1. But we can move this double bond to carbon number 2. So the structure will be but 2 in. That's why we have shown there. That is what we are going to do now. Those are what we are going to do, which we refer to as isomers. Remember, I said we'll do naming of structures and then we'll do isomers. So it means when we have now 2, we have but 1 in and but 2 in. So you can see that those are isomers. So we're going to do isomers. You will know that, oh, now isomers, how do I know what type of isomers and all that? We're going to introduce them using they come from there. When you double bond, we have 2 options, either in carbon number 1 or carbon number 2. You can see when you go to pent, the options start to increase of number of isomers. You can have pent 1 in, pent 2 in, pent 3 in, all that. You can have that. So you can see that as we are moving now, as we are moving around now, the number of isomers are increasing as well. So we have so many isomers, then we'll refer to them as we reach that. So I hope this slide was able to explain everything, to say first thing first, the number of carbons, which gives us the what? The prefix. When you know the number of carbons, if it's map BPH, remember, said 6 carbons is X. Then you go and check whether it's a double bond, single bond, double bond, or triple bond. If it's only single covalent bonds, we said it's alkanes. They are saturated. So you know that when it's alkanes, you'll put an A. So that ane is because there are no double bonds between carbon atoms. Where immediately when we remove two hydrogens, we're moving from alkanes to alkenes, but the number of carbons is still 6, so it will still be hex. So hence we're having hex there. But we're saying in carbon number 1, we can have a double bond. So it's hex 1 in. We can have it in hex in carbon number 2, in carbon number 3, like that as we continue, and even for alkynes. I hope this slide it is explained. Hydrocarbons. Remember, these three are hydrocarbons. So you must sing and enjoy hydrocarbons in order for you to enjoy organic molecules, because we're just moving from here to other homologous series, which are really derivatives of these hydrocarbons. Now, remember what I said. These structures, they can be they can have single covalent bond, double covalent bond, or triple covalent bond. We talked about that. But I said the structures can be branched or unbranched. So that is the first thing that you must understand. The structure can have branches, or for example, if it's just a straight chain like that, we say this structure is unbranched. But it's unbranched what? It's unbranched alkane. It's unbranched alkane. Why do we say this is an alkane? Because it's saturated. It has a single covalent bond between carbon atoms. This one is unbranched. Unbranched what? Alkene. It's unbranched alkene. Why do we call it an alkene? Because it is a double bond, which means we have removed two hydrogens and now we have a double bond. Now, if now it's like that, it's still unbranched because it's a straight chain. You can see that this is a straight chain. We are having this carbon after this, they're just moving straight. This one as well, straight chain. You can see straight, but it's an alkyne. Why do you know that it's an alkyne? Because of the carbon-carbon triple bond. Learners, don't be confused. If I write, for example, the same structure like this, like that, the structure, this alkane, the first one, the alkane. If I write it like that, you don't be confused and think that this is now branched. It's not branched. It's still a straight chain. It's not branched. It's still a straight chain. I want you to see that. As long as you are able to, without lifting this pen, if I'm writing here, if I'm able to draw this line without lifting the pen, it shows that this is what is a straight chain. It's a straight chain. It's just that we wrote these carbons going that side, the other carbons moving the other side. So don't be confused. Sometimes in the exam, we take these structures, we put it like that. Then you think this is branched. No, this is not branched. It's a straight chain. It's the same as this one. It is, if it's how many carbons? 1, 2, 3, 4. So it's both. No double bonds. So it's ane, it's alkane. So this is butane. This one, as we said, how many carbons? 1, 2, 3, 4. So it's still both. The double bond is in carbon number 2, so it's both 2 in. Don't forget the hyphens when you are writing between the alphabet and the number. Those dash, we like them. So be careful of that. So if I draw a straight line here, this is straight chain. If I draw a straight line here, this is straight chain. Straight line here, this is straight chain. Straight line, I'm still drawing the same line. I can't lift my pen, straight chain. But now, look now when I come to draw this one. If I now draw a line like that, for me to go to the other CH2, CH3, CH2, you see that now I have to lift a pen and come and draw again here. So you can see now it's making a T. Then you know that this is what is a branch. So you must be able to see whether the structure is branched or unbranched. So I'm saying one of the ways you can draw that line, it will show you. I draw a line. Now I see that I didn't cover all my carbons. I must draw another line. It's giving me a T there. Then I know this is a branch. Draw a line like that. I know this is what is a branch. So you will be able to differentiate between branched and unbranched hydrocarbons. So we're saying our alkanes, alkenes, and alkynes, they can be straight chains. Straight chains, we refer to them as unbranched. They can be branched. When they have branched, I've shown you a good skill to say, if they're giving you a T there, you know that we have a branch there. But if you can draw a line between all those carbons without lifting your pen, you know that this is a straight chain. Because most of the time, you make that mistake and then you are now having a problem of not differentiating between branch. Because we can give you a structure and say, is this a branched or unbranched? Remember, learners, when you go to do the isomers as well, the branch and unbranched, they will be able to give us isomers. You will see when you do the last part of this session, you will be able to see that we are able to do that. Now we're going towards now naming of all these structures with no problem. So remember, we said CH4. We said carbon. Each carbon must have 4 bonds around it. That's what we said today. And we agreed, me and you, that CH4 is carbon is tetravalent. It forms 4 bonds around it. Now, if you find a carbon like this one, CH3, you know carbon must have 4 bonds. So you know that, no, there is a hydrogen short there. Then you must know it's no longer an alkane. Remember we said CH4 is an alkane. Because of 1 carbon, we said it's meth. And because of the ane in the alkane, it's a methane. Remember that. So if we have a methane, for example, like that, but it's running short of 1 hydrogen, like now it's a CH3, as you can see there on our table. It's a CH3. A CH3, we no longer refer to it as an alkane. We'll now refer to as alkyl. So what is an alkyl group? We refer to this as an alkyl group. An alkyl group is a group formed by removing 1 hydrogen from an alkane. So when you have an alkane, you remove 1 hydrogen, you are forming an alkyl group. So you have to know how to form an alkyl group. When you remove 1 hydrogen from an alkane, you form an alkyl group. I hope you have understood that. So when you have a structure that has a CH3, we'll talk about that as a branch or as a side chain, then you will refer to that as an alkyl group. Alkyl group. If it's 1 carbon, if that structure has 1 carbon, we'll refer to it as methyl. Remember from our map BPH there, we said 1 carbon is M. Remember, I'm always referring to this because I don't want you to forget this map BPH all the time. To say, okay, how many carbons do we have here? 1. So you know it's a meth. But because it's running short of hydrogen, it was supposed to be methane. But methane is CH4 because carbon is tetravalent. Carbon forms 4 bonds around it. So because it's running short of 1 hydrogen, it's not a methane. You see, it's a methyl. So we have formed another group which is referred to as a methyl. If you look at the second structure, it's 2 carbons. 2 carbons is supposed to be C2H6. So we're running short of 1 hydrogen as well is it. But because we're running short of a hydrogen, alkane minus 1 hydrogen, it gives us alkyl. So you know that. So this will be ethyl. So when you have a branch that is a CH3, we refer to it as a methyl. When you have a branch that is having 2 carbons, you will refer to it as ethyl. I hope and pray you have understood that. That okay, we know methane, we know ethane, but if it's 1 hydrogen short, as a branch, remember as a branch, you can't, when you are having a structure like that, and then you have, this is CH3, this is CH3, this is CH3. So if you are having a structure like that, which is a CH3, it's not a branch because it's part. Remember, I said, how do you know whether it's a branch or not? I said, draw a line. Draw a line. Without lifting a pen, you must be able to finish with your line. Doesn't matter where it is going. So if I draw a line like that, you can see that this is part of the longest chain. So it's not a branch. It's only a branch if I'm having, for example, the CH3 there, the CH3 here. Now you know that because if I draw a line, I will draw it like that, or I'll draw it going down. So one of them will be a branch. So this is a branch. It's a CH3. So the branch, you can't call this methane. You will refer to it as methyl. Why? Because this is CH4, but you have removed one hydrogen. So because it's running short of one hydrogen, it's no longer an alkane, it's now an alkyl group. So you understand the alkyl groups to say, for us, when we're having alkyl groups, it simply means that we have removed one hydrogen. So because one hydrogen was removed, it's no longer, but it must be a site. It must not be part of the longest carbon chain. You can't have a CH3 as part of the longest carbon chain and you refer to it as a branch. No, remember I showed you how to see the branch. Said let it give you that T. When you're drawing it like that, then you see, that's a branch. That T is a branch because we have that and that. So you see that, CH3 is a branch. Even if you draw going down, you can draw your line from this carbon going like that, going down like that. This would be your longest carbon chain. This becomes now your branch. So this can be a branch or this can be a branch. It doesn't matter. So this is still one longest carbon chain. So I'm saying that so that you are able to understand at all times. So we're saying you refer to it as methyl. Now we are going now to real naming of structure. If this structure has two carbons, you will refer to it a branch. If a branch has two carbons, you will refer to it as ethyl. So it will be ethyl. We for technical science grade 12, we only do these two side chains, which is the methyl and ethyl. So you won't have a very long like propyl with three carbons. No, it's either it will be one carbon as a one carbon or two carbons. So our branches is a one carbon branch or two carbon branch. We won't have a branch of more than three. So in the event you are coming across more than two carbons in a branch, you must know that that might be part of the longest carbon chain, because our longest carbon chain, our branch, I wanted to say our branch must at all times either have one carbon or two carbons for our studies. As and when you pursue your studies, you can have propyl and butyl and longer side chains. But for our studies, we only do methyl and ethyl. So I hope you have understood the issue of branches. Remember, I'm bringing you back now. I'm saying we've done straight chains. Now we have done the branches. For the branches, we're saying the branch, our side chain, it can be methyl or ethyl. But look at the name there. We said substituent, branch, or side chain. You see, I like most the branch and the side chain when I'm referring to methyl and ethyl. I like to refer to them as branches and side chain. However, they're substituent because they've substituted a hydrogen. So they substitute something there. But the best name would be branch or side chain. Yeah, refer to them as branch or side chain. But we can use the word substituent. It will fit as well. Remember, our substituent is not always methyl and ethyl. We can have other substituent, but not branches or side chain. The side chains, there are only two, methyl or ethyl. The branch is either methyl or ethyl. The others will refer to as if we have any other substituent. Remember, we're having a long carbon structure of butane, for example. We had a butane as a structure. Hoping you can see my drawing. Let me put it here. We had butane as our structure with the hydrogens. Remember what we said? Carbon must have 4 bonds around it at all the times. Don't make that mistake all the time. Count the number of bonds around each carbon. So if we're having butane as a structure, if we want to put a branch, we will remove that hydrogen there and put a branch, maybe a CH3 there. So we'll say it's a methyl. If we put a CH3 there, it will be methyl. If we put a C2H5, it will be ethyl. So you see now, hence we are saying it's a substituent because it's substituting, we are removing a hydrogen there in order for us to put that branch. So hence we are referring to it as a substituent, a branch, or a side chain. So you have to understand. And then we are saying only our branches is only methyl and ethyl. I didn't talk about substituents because we have many substituents which can be chlorine and all that, which we are going to talk about as substituents. Substituents, we can have chlorine, we can have bromine. So as our substituent. So I wanted us to move from there. Now, you will understand, as I indicated, that this lesson is meant for you to have a foundation for this topic, because if you understand everything that we have done, you must be able to say, I'm ready now to do the rest of these sections. So I don't want to unnecessarily being in a hurry. I want you to move with me, because when I started, I defined for you what are organic molecules. You said they are made up of carbons only. Organic molecules made up of carbons only. We said these are our organic molecules. Organic molecules, they are made up of carbons. They have carbon in them. Now we moved as well. We said what are homologous series. We said our homologous series, they have the same, they're described by the same general formula. I've shown you for alkanes, I've shown you for alkenes, I've shown you for alkynes. CnH2n plus 2. When we move to alkenes, it was CnH2n. When we move to alkynes, it was CnH2n minus 2. So you understand the issue of the general formula. We said for us to move from a general formula to a molecular formula, we'll substitute the number of carbons. N stand for the number of carbons. So you saw how we move from general formula we were able to move to molecular formula. From there, we draw a structural formula which it shows all the bonds that are involved. So I wanted to bring you where we are. We said we can have a straight chain, we can have unbranched and branched hydrocarbons. We have shown you branched and unbranched hydrocarbons, alkanes, alkenes, and alkynes. So we have shown you the branch. How do you determine? How do you know that we have a branch? And we said for our branch, we only do 2 branches, which is methyl or ethyl. Methyl is like methane that is running short of 1 hydrogen. So it's a CH3. Ethyl is like ethane. Immediately when you remove 1 hydrogen there, it becomes an alkyl group. So that ethane, it becomes ethyl because it's running short of 1 hydrogen. But I said all the time, start by identifying the longest carbon chain so that you know which one is a branch, because a shortest carbon chain cannot be the parent chain. The parent chain is always the longest carbon chain, and we're going to use the map BPH in order for us to be able to see whether which one is the parent chain. Then we look for the branches. I showed you with the drawing of the T there so that you are able to see that how to see whether we have branched or unbranched structures. Now, remember what we're doing. It was AAA, which was our alkanes, and alkynes. I spent a lot of time there because I wanted you to understand. Now we are left with this other group now, which is our aldehyde, ketones, esters, alcohol, and carboxylic acid. So for these ones, we are going to say the prefix now, it won't be meth. Remember we're saying meth, eth, prop, but, pent, hex. No, we're saying for the last 5 homologous series, our prefix, let it be methane. So you're taking the whole struct name, methane, ethane, propane, butane, pentane, hexane. All you are removing is the last E. From alkanes, you are removing an E. So you will understand. It will make sense to you. Don't worry. So I'm saying for you to name aldehydes, for example, we're going to the next groups, which you will have now: aldehyde, ketones, esters, alcohols, and the carboxylic acid. That are the other 5 homologous series that we're having. Carboxylic acid. So I'm saying for aldehydes, all you're going to do, we're having methane there. So all you're going to do is to remove the E. Then you take the al there. So you will say methanal. You see? Unlike with the hydrocarbons, we said meth. Now we are saying you write methane, but now you only take the Al there, then it becomes methanal. Let's go to, for example, if it's an alcohol, for example, you will take the OL there. You will say ethanol. If it's a carboxylic acid, you will say propanoic acid. You see? So we are now taking the last part of the name, carboxylic acid. So oic acid, that's what we'll take and put there, propanoic acid. So if you are having a ketone, for example, you will see when you do ketones why I intentionally didn't talk about ketones as in one carbon. You will say butan, then you take the own there. So the name will be butanone, pentanone, hexanone. So you will see that the prefix now becomes the methane, the entire alkane without E. All we are removing for the last five, I don't know why I refer to them as last, but the last five homologous series, we are saying that we do in technical science. We are saying you will write the prefix as the entire alkane without E. So all you are removing is the E, and you replace the E with our suffix there, which is coming from the homologous series. So our next session that we are going to focus on, we'll be looking at all these other functional groups. Remember, we said a functional group is a bond. You see this red, the functional group there in red there. It's a bond. You see one bond for alkanes, double bond for alkanes, triple bond for alkynes. So you can see that's a functional group because that's what we're going to do. Remember I said, how will you differentiate your homologous series? I said you will differentiate them by functional group. The functional group is the one that shows the difference between them. So you know the functional group here is a carbon-carbon double single bond, carbon-carbon double bond, carbon-carbon triple bond. So we're saying a functional group, that bond is showing us this number of bonds. They're showing us the type of the functional group or the homologous series which they belong. Now, if you look, we're saying it's an atom. So this X, it stands for halogens, group 17 elements in the periodic table. So we'll go through haloalkanes in detail in our next session. So make sure that you attend that session. So we're saying for haloalkanes for grade 12, we're only doing bromo, Br and Cl, bromine and chlorine. So we only do bromo and chloro. So we don't do the other fluoro and iodo. We only do those two. So you will see we'll be using bromo. So you can see. So we're saying a functional group is an atom. You can see that X, it stands for bromine or chlorine in our case for technical science, grade 12. We are saying it's a group of atoms. Look at the OH there. The OH there is a group of atoms because it's oxygen, an atom from the periodic table, and hydrogen, another atom. So we're saying a functional group is an atom according to the exam guideline. A functional group is an atom. It's a group of atoms that determines what? The chemistry of a molecule. So when you want to know the chemistry of the molecule, you will look at the atom, group of atoms, because this atom or group of atoms, they will determine the chemistry of an organic molecule. So I'm wrapping up there by saying now know all these functional groups. Remember what I said. For each functional group, you must know general formula, molecular formula, and structural formula. So you got to do that. For each of these homologous series, we have only 3 formulas for organic chemistry, tech science, grade 12. We have 3 formulas: general formula, molecular formula, and structural formula. There is another formula that we refer to as condensed structural formula that I will show you for the sake of your understanding as we do our next lesson. However, we focus on the general formula, molecular formula, and structural formula, which are the things that I've been doing today. I've ensured that you know the difference, and I'm hoping that you know the difference between general formula and from general formula, when you replace the N, you get the molecular formula. When you have molecular formula, you show all the bonds, you get your structural formula. This was such a wonderful lesson that we had. I'm hoping you enjoyed it as I did. I'm looking forward to our future engagement. And remember, we have aldehydes as well. The general form, they are functional group. These functional group, they have names. So in our next lesson, we'll look at the names of the functional group. What do we call for the aldehydes? What do we call what is the name of the functional group? Is formyl group. So we'll be talking about that. We'll be talking about such when we meet the next time. So it's very much important. We have ketones, we have carboxylic acids, we have esters. So those are the last part that we are going to do, so that we do that. Then from there, you will see how we form esters, because for us to have esters, we're going to combine alcohols and carboxylic acid, so that we can form this. It's a very interesting type of a reaction. So we'll do that in our next engagement. I'm hoping that you will be there, and then you will ask as many questions as you can, so that we are able to move forward, and you will enjoy. So we still have a lot that we will do. We'll talk to the types of alcohol, as I indicated at the beginning of the lesson, that you must be able to differentiate between primary, secondary, and tertiary alcohol. So those are the things that are of paramount importance. I hope you have the picture of this section. Homologous series, 9 of them. AAA, Hague, AC, remember all of those. So we did the first 3, which we refer to as hydrocarbons. We said they're made up of hydrogens and carbons only. The word only, we underlined it because we said it's the most important thing. These hydrocarbons, we said they're either saturated or unsaturated. So you have to know that it's either they're saturated or unsaturated. Remember, saturated, we said it must be carbon-carbon single bonds, that is saturated. Unsaturated is carbon-carbon double bond or carbon-carbon triple bonds. How do we go there? We remove 2 hydrogens from alkanes, we become an alkene. When we remove another 2 hydrogens, it becomes an alkyne. So our general formula, we saw it was CnH2n plus 2. We removed the 2 hydrogens, it became CnH2n. We removed further 2 hydrogens. When we form alkynes, it became CnH2n minus 2. And then we indicated how do we go about naming. We talked about the issue of prefix. I hope and pray you've understood all those prefixes that we had. And then you would be able to refer to our map, BPH, to say how many carbons do we have in the longest carbon chain. How many carbons do we have? Then when you count them, if there are 5, you know it's pent. So you look at the homologous series to say, oh, because there's no double bonds, there's no triple bonds, it's only carbon-carbon single bonds, it's an A. So it becomes a pentane. So that is how you go about doing that. We'll be doing a lot of questions as we continue with our future lessons. I had some questions that I would like us to deal with. We will do them as we meet in the coming future. You can see this question. It says, to which homologous series does the molecule C8H14 belong? So it calls for you now to go back to the general formula to say the general formula is CnH2n plus 2. So how many n? N is 8. When you replace C8, H 2 times 8, it will give you 16 plus 2 is 18. You know that this structure is supposed to be C8H18, which is an alkane. So if you remove 2, it will be C8H16, which is an alkene. If you remove another 2, it will be C8H14, which is an alkyne. So you know that, oh, this one now is an alkyne because we removed 4 hydrogens from the 18 that we expected from the alkane. So the general formulas are important because this is an exam question from previous paper. Then you are able to answer that question. So you will see as we move. Remember, I said for haloalkanes, we represent bromine and chlorine with an X. So you will get this question that says, which one is the general formula of haloalkanes? You will come and say, okay, CnH2n, you know it's alkenes. CnH2n minus 2 alkynes. So you'll say this is an alkene. You'd say this is an alkyne. You will say this is an alkane. This is an alkane. Then you know that all of this are your things. So your answer will be D. Thank you very much. I had a wonderful time. Looking forward to our future engagement. Thank you very much.